proportionality theorem is basically line dividing the two sides of triangles in the same proportion. But before we study the proportionality theorem, we need to learn about preliminaries. How do we go about proving the proportionality theorem, right? So if you can understand these basic stuff, then you will be able to prove the proportionality theorem, right? You can understand the theorem basically. And that's what math is about. It's about understanding, okay? Right, so let's look at the first types of triangles that we need to look at, right? So what we have here is a ratio of areas. Now, what's the ratio of areas? You're taking one triangle area and dividing it by the other area. So in this case, what we have is something called a common height. Now, where's the common height in this triangle? See what we want to find. Point BD lies, right? Point BD, okay, line BD lies on segment AC, right? It's a line segment. You don't need to use the word segment. Line segment means it's a line. Segment BD is drawn. Segment BD is drawn, right? That's another line segment. Splitting triangle ABC into triangles ABD and BDC. So you split up into two triangles. Obviously, this line segment BD split this triangle into two triangles. AD is equal to 15, so we're going to fill that in. AD is 15, right? And DC is 20. They didn't mention the units of measurement, so it's fine. Now, what do we want to find? We want to find the area of triangle ABD over area of triangle CBD. Now, what we see here, to find area of triangle, how do we find the area of triangle? To find the area of triangle, it's just half base times perpendicular height, half base times altitude. So let me draw one altitude here, right? Altitude means the perpendicular height. So I'm going to draw a common altitude, which is common to both the triangles. I'm trying to draw a height here. Okay, so I drew the height. Let me draw it in broken lines so you can actually see what it is. Right, so this is the height. Right, now I want to find the ratio of area of triangle ABD, triangle 1 to triangle 2. Now, you can see this is an obtuse angle triangle, so the altitude is on the outside. It is still half base times height. Remember, area of triangle, you got area of triangle, which is half base times perpendicular height. Or you can use the area rule, which is half AB sine C. Half AB sine C. Right, we're coming to that. Let's work with this. So how will we find the area of triangle ABD? Area of triangle ABD is half. What's the base? ABD. So I'm looking at triangle 1 on the left. The base is 15, right? And the height is H. That's why we say it's a common height. Between the two triangles, we have a common height. So, but we don't have a height because we have created it, right? And then same here, we got half. What's the base of this triangle? The base is here. CD is the base, which is 20 times the height. Now see what happens now. The half and the half cancels out. The H and the H cancels out because we're trying to find the ratio of the areas. So what we got, 15 out of 20, which is 3/4, 3/4, okay? All right, guys. Let's look at a problem. Now, remember what we used here? We use half base times height, okay? That's area of triangle. Now, what happens in a second case, which is common angle? When do we get common angle? Look at the way this triangle is structured. Now, you can't draw an altitude which is common to both. Example, in triangle ABC, the big triangle, points D and E lie on AB and BC respectively. D and E lies on AB and BC respectively. Right. Length BD is equal to 3. BD is 3. DA is 13. DA is 13. EB is 5. Right? and EC is 12. Okay, so those are the lengths that we have. But now we want to find the area of triangle BDE, which is the small triangle over the entire big triangle ABC. So what's happening in this case now? Triangle 1 over triangle 2. I can't draw a common altitude, okay? I can't draw a common height because I don't have a common vertex. See over here. See, I had a common vertex, so I can draw a, see what it says, common height, same altitude, right? Now over here, I actually have something called a common vertex. I do have a common vertex, so I'm gonna call this angle B. So I can't use half base times height, right? Because it's impossible for me to draw an altitude which is equivalent for both the triangles. So there's no common altitude, there is a common vertex or common angle. So what's the area of triangle BDE? Now remember to find the area of a general triangle. Just revising here. So if I call this A, this is B, that is C. So opposite this is A, opposite this is B, opposite this is C. So all you need to do is multiply the two sides, take sine of the angle and divide it by 2. So that's why we say area is equal to half, multiply the two sides because you must have side angle side to calculate the area. You must have the information side angle side. So half BC sine A. So that's what we have. We do have the information which is side angle side. There's your angle here, angle B. So I'm gonna write down what's area of triangle BDE. BDE. So there's B. We have side angle side. So it's half times 3 times 5 sine of angle B. We have a common angle. And we're going to divide it by half ABC, all right? So what is AB? 3 plus 13, which is 16. 3 plus 13. Be careful, don't write 13 now. 13 is the length of AD. So 3 plus, and this is 5 plus 12, which is in sine of angle B. And guess what? Even over here, we have cancellation. Sine B cancels out. The halves cancel out, okay? And now we can get the answer, which is 3 times 15 is what? 16. No, 3 times 5 is 15. So now we have 15 out of 16 times 17. I'm just going to use the calculator for that, right? You're allowed to use a calculator, use it, right? 16 times 17. I'm getting 272. Right? What is 15 over 272? 0.05. 0.05. 0.055. Please don't write those percentage. I'm just trying to explain to you. You're going to leave your answer like this, all right? Yeah, you can leave your answer as 0.055, but avoid that. Leave your answer as a fraction is more. I'm going to explain to you what this ratio means. Right. This ratio means that it covers approximately the small triangle covers approximately 5.5% area, right, of the big triangle, because we're taking a ratio of areas, okay? It covers approximately 5.5% area of the big triangle, right? It's like, think about tiles now. How many percent of the area are you covering of the big one? 5.5%. All right, so you don't need to write all that out. They don't even ask you for an explanation. They just ask you to find the ratio of areas, right? Now, next concept is we have done areas. Next concept is to do what is same base, same height between parallel lines. So here we have a diagram, right? Don't focus on all this here. Just focus on the diagram because this will help us prove the proportionality theorem. Look at this. Look at this diagram. In this diagram, we have these two lines that are parallel, okay? So what we have We have parallel lines. Perfect. So this is a concept of same base, same height. So two triangles that are on the same base. Where's the two triangles that are on the same base? Look at this. There's the two triangles that are on the same base. Okay. See what this conjecture is saying. You see what this theorem is saying. The two triangles on the same base is triangle FDE, right? And we got ECD or CDE. Okay. It's on the same base. What he says is that the two triangles that are on the same base will be basically will have the same area, right? This is a congruency sign, should have been equal to, so area of triangle CDE must be equal to the area. Congruent means must be identical area. So this is a concept of same base, same height. Let me draw it in the side here, right? So here's a parallel line. If you try to draw altitudes in the parallel line, no matter where you draw altitudes, right? There I have a parallel line. Let me tilt this parallel lines a bit, right? There. These lines are parallel. Now I'm going to draw an altitude here within the parallel line. So altitude means 90 degree. If I draw 90 degree here, this is the height, okay? Right, that's the height. Now, between any parallel lines, you can draw another altitude here, right? The height will be exactly the same. Why are the heights exactly the same? Because parallel lines are equidistant. Okay, we know parallel lines are equidistant, so obviously this height will be equal to that height. That is one. Now, what I'm going to do here is I'm going to extend this parallel line, right? Let's extend this parallel line. So you can see the same base is DE is the same base. So I'm going to draw a height here as well, right? So I'm going to draw a height from, try to draw a height of these two triangles on the same base. But the height of this will be on the outside, right? Exactly what I drew there. That's what I want to draw here as well. Okay, there's the height. Right, that's a height on that side, or it can be this side because alternate angles you can take and I'm going to draw another height here as well. Maybe this height is for that side. I just try to, yeah, there's another height here, right? So if I try to find the area of this triangle, is this half base times height, right? So that's the reason why we say as long as you have the same altitude, if the two triangles have the same altitude and the same base, then the areas of the two triangles will be the same. Look at this base. Base is DE, and there's two triangles sitting on this base DE. So we say area of triangle CDE. Where's CDE? CDE. This triangle here, right? Which is 1, is equal to area of triangle FDE. FDE. There's triangle 2, right? So those will have equal areas. And the reason is same base, same height. And we need to use this for the proportionality theorem. And what's the reason? Same base, same height. That's the reason we use, okay? Same base, same height. And same here, what's area of triangle EFC? Now, if you go across on the top, you see that you also have, this is the base between the parallel line. We have another base here. We have, just say this is base 2 and this is base 1. We are done with base 1. Let's look at base 2. There are two triangles that are sitting on base 2 between the same parallel line because they have the same height, same base, same height. That's the reason. Now, so we have triangle EFC, EFC, and we have triangle, what it was, EFC, and we have triangle DFC, DFC. All right, guys. Let's look at this first part that I did. Area of triangle CDE? What's area of triangle CDE? Give me the answer. Is half, what's the base? DE times, what's the height? I drew a height here, which is H. And if I ask you what's area of triangle FDE, you're going to tell me the same thing is half. Where's FDE? FDE. You got the same base. So DE times height. And now you can clearly see that these are equivalent. That's why we say same base, same height has areas that are between the triangles that are between the parallel lines, and they have the same base, same height, have equal areas. Okay, so clearly this, I hope this is clear now. Are we good, Mishka? Now, we good?
Yes, sir.
All right, excellent. Now, you only need these two information. See, you need this information about the altitude, and you need this information about same base, same height to prove the proportionality theorem. Now, before we move on to the proportionality theorem or prop theorem, let's take an example of this, which is represented here, okay? So let's see. We have in the sketch, AE is parallel to BD. AE is parallel to BD, that's given. Point D lies on lines EC. All right. Make sure you read everything. ED to DC is 7:15. They just gave us a ratio. ED to DC is 7:15. ED to DC is 7:15. Remember, this is a simplified ratio. So it could have been 14:30. So in other words, is missing a factor. So that's the reason why we don't say 7:15. We say ED is 7x. And what is DC? DC is 15. So we write 15x. Okay, you don't write 7 and 15. You write 7x and 15x. Now we want the area of triangle ABD. Area of triangle ABD. This is 1 over the area of triangle BDC. BDC. All right. Are we good? Area of triangle BDC will be, okay, we'll figure that out. So we want the area of this triangle or the area of that triangle. But now look at this. We have a parallel line which is going this way. So can we use the concept of same base, same height? Can we use the concept of same base, same height here? Area of triangle ABD. What we have just learned here. Remember the parallel lines are here, right? If the parallel lines are here, then let's look at this example over here now. Area of triangle ABD. ABD. Is the lines correct? ABD. Okay. If you remember clearly from the previous problem, area of triangle ABD, let me just write this down. Area of triangle ABD is equal to half. What's the base? BD. Right? And what's the height? We need like a common height here, right? Where's the height of this triangle? Let me extend this parallel line here. That's the reason why I'm getting correct. 1 second. Let me extend this parallel line here so you can also see it. Because I'm using the concept of same base, same height, okay? Right, so I'm going to draw a, remember, I need an altitude for this side, right? That's a height. And obviously I will have an altitude on this side as well, all right? Will have height, I will have a height there as well. So we got half BD times height. Where's another triangle that is sitting on this same thing over here? We have half area of triangle, what we said, ABD, then EBD. See, we have a second triangle which is here between the parallel lines, same base, same height, okay? Triangle EBD, which is half BD times height. And you can see that they are equivalent, right? So we know the area of triangle, we know the area of this triangle 1 is equivalent to this area of this second triangle here. And what do we want? We want the area of triangle ABD. So what is the, oh yeah, this is perfect. Now, so what is the area of triangle ABD? Area of triangle ABD, we can replace area of triangle ABD with area of triangle BDE. Now, let me map this out for you. Let me trace this out for you and move it to the side. Otherwise, you will not be able to see it. I'm going to remove this entire triangle, okay? I'm just tracing it out for you so you can actually see it. Right, so great. Now watch what I'm going to do. I'm going to move this triangle here, isn't? Because I moved this entire triangle 2, right? The green 2, right? Because 1 and 2 are equivalent because it's on the same base, same height. So we're going to say, so that's what I've done. So now I can see from this triangle that I pulled out, BEC, triangle BEC that I pulled out, I have like a common height, right? So I can use half base times height and half base times height for the second triangle. But now before you do this, before you start writing anything, you have to go and write it out over here, okay? So you have to write this part out first and then start solving the problem. Right, so we need to say they are equivalent, right? Why it is equivalent? They are equal because same base, same height. Right, that's the reason why they are equivalent. Now you can complete the, now you can do this problem here. Done. Now you can find area of triangle ABD. Now remember, I removed the trace of the whole thing and I put it on this side. So this is 7x and this is 15x. So what's the area of triangle ABD? Same as area of triangle EBD over area of triangle BDC. Now, what's area of triangle EBD? Half EBD, all right? EBD. Half, what's the base? Base is 7x. And what's the height? H. Area of triangle BDC, BDC. Half 7x times height. Not 7x, sorry. Supposed to be 15x. Now you can see the halves cancel out, the x's cancel out, right? Most of them cancel out. You can see the halves cancel out, the h's cancel out, the x's cancel out, and the answer is just 7 out of 15. But you're not going to get full marks if you're just going to write 7 out of 15. You have to show this work. This is like bulk of the marks, right? You will definitely get marks here for writing all this out. Okay, so this was kind of confusing. All we've done, first thing, is we took this triangle, same base, same height between parallel lines, and then we saw a picture here. We said, okay, this has a common altitude, common height. It's not a common vertex, it's a common height. It's not a common angle, it's a common height. Right, now we come to the proportionality theorem. We're actually doing the proof now, okay? Now, how do we construct the proof? There's a diagram here. We want to prove that AD over BD equals AE over EC. Okay, that's what we want to prove. Now, what we are given, a line drawn parallel to one side of a triangle, a line drawn parallel to one side of a triangle. So we're drawing this line parallel, which is DE, right? Divides the other two sides proportionally. So this is the prop theorem. And that's the reason you write in the prop theorem. Right, so how do we go about proving this theorem? What we want to prove is we want to prove AD over BD, right? There's a point here. AD over BD equals AE over EC. And all you need to do for this is take a ratio of areas. We are required to prove, by the way, guys, you don't write this initially. This is the reason that you provide when you are using these conclusions, right? Now, how do we go about proving this? So we're going to make two altitudes, right? So we're going to make an altitude here. Right, so first you make your crosses like this. Join B. I need to write all this out. Proof. Right, so you're going to say construct line lines BE, but in this case it was already given, but if it's not given, just a general diagram is given. That's what you're going to do. Construct lines BE and CD and altitudes from D to AE, call it H, and draw another altitude here. Right, draw another altitude from point E, okay? Draw altitudes H and K on H is on what? AE and AD is where the K is, respectively. Okay, now the proof starts. This is the proof. You're going to take ratio of areas. Ratio of what areas you're going to take? You're going to take look at this triangle first. I want you to focus on this triangle. Remember, we have parallel lines, all right? So we're going to choose triangle ADE, right? Because we want AD and we want DB, all right? So we're going to choose EDB, okay? So you're taking a ratio of areas. Area of triangle ADE, because you want AD, so make sure AD appears there. You want area of triangle ADE over area of triangle, what? You said ADE. So DB, DBE. Okay. So now you can see that AD and DB appears there, but remember that's part of a triangle and this is a line. So now we need to show some calculations, how you find area of triangle ADE. Remember, that's the reason why we drew an altitude. You're only looking at this half of the triangle. Look at triangle ADE, right? And look at triangle EDB, right? So you're focusing only on this side. How can I draw this? Right, so you are only focusing here. Okay, your mind is only focused on that half. Okay, and there's your line there. So if you're focusing on this green part, where's your altitude? Your altitude is K. So you're gonna say half, what's the base? AD times K. Divide by half. What's the base here for the second triangle? BD times H. No. What's the altitude there? K, still K. So now what happens? The halves cancel out, the K's cancel out, and what you got? AD over BD. And that's only, now the next part you take a ratio on the other side now. Now let me take this green part out. We're taking the ratio on the other side. Now you're gonna say area of triangle AED. Over area of triangle. So I'm looking at this side now. It's so easy, guys, to do the proof. That's why I did ratio of areas first. I started off with that. Right. So looking at this triangle, yeah, sorry about the drawing. Right. And looking at that triangle. Now, what's your altitude for this triangle? There's your altitude here. The altitude is H. Okay. Uh, let's use another color. Right. Right. So if I want to find the area of triangle AED over area of triangle CED or ECD. You see, I'm kind of like cheating over here. See, you got AE over EC. Check there. You got AE over EC. Make sure you have that. So what's the answer? Half. What's the base here? AE times half AE times what's the altitude here? H. Divided by half. What's ECD? EC times H. Now what happens? We can go and cancel out the halves and we can cancel out the H's. So what we have now? AE over EC, right? Just one second, guys. Right, now we have a bigger problem because now we need to prove that these two ratios are equal. That's what we want to prove, right? We have done bulk of the work. Now we want to prove that these two ratios are equal. How are we going to do that? To prove that these two ratios are equal, remember we have a parallel line inside the triangle. So I'm going to take out all these things now. Now focus on this. Right, so I'm going to take out, okay, let's leave the H and the K. I want you to focus on this. That one, right? This line. Right? That one, and okay. Let's take this bottom lines out. We only need to focus on DE, all right? Yeah, I want you to focus on these two triangles. What's happening in these two triangles here? Don't these two triangles have the same area? Don't these two triangles have the same area? Why? It's same base. Look at this. It's the same base and it's between the parallel lines. So it's going to have the same altitude, same height. Okay. Same base, same height problem again, because where's the height of this triangle? It's on the outside, but it needs to be within the parallel line. There's a height here. Where's the height of this triangle? It's an obtuse angle triangle. So there's a height on the outside. Okay. There's a height here. So let me take those heights out. Right. So you understood that. So what we have here is we can say area of next part. This is the crux of the problem because it's easy to find the ratio of areas. How do we equate these two? That's what we're trying to find. So now we're going to say area of triangle BDE is equal to area of triangle CED. Okay. And what's the reason for this? Why are we saying that these two areas are equal? We are saying these two areas are equal because same base, same height. Same base, same height. You can write same base, same height between parallel lines. Between parallel lines. Okay. You don't have to write between parallel lines. Just same base, same height should suffice. All right. Because it has to be between one of the conditions for same base, same height is that it has to be between parallel lines. So that's it. Same base, same height. Okay. Now, if you are saying that area of triangle BDE is this bottom part of part 1 ratio, and area of triangle CED is from the second ratio, the bottom part, but the top part is the same, which means that these two ratios are equivalent. This implies area of triangle. Now you have to write out all this, okay? This implies the two top ones, the two areas on top, right? They are equivalent. It's equivalent. The top ratio is equivalent to the bottom ratio. Okay, since these two ratios are equivalent, see, clearly we just proved that these bottom things are equal because of same base, same height. And now what was this? This was AD over BD is now equals to AE over EC, right? And whenever you make this conclusion, you have to say your reason. I think, guys, this is done. That's proved. Reason. The reason that you will mention as soon as you make the conclusion like this, you'll always say prop theorem because DE is parallel. You have to mention, whenever you say prop theorem, you have to mention the pair of parallel lines, which is DE is parallel to BC. Any questions? Right. That's the reason why I taught you the concept of same base, same height, because it's a very confusing concept. Now, because you have understood it well in this example here, we had no issues in proving the prop theorem because you already knew the preliminaries. Okay. That's why I started off with the ratio of areas, because we need it for the prop theorem proof. All right, guys. Now the applications are very simple, because what are we saying? We're saying AD over BD equals AE over EC. That's what we are saying. This line divides the other two sides of the triangles in the same proportion. Now let's look at some examples. Now we're only solving examples because we are done with that's the main proof that you will be examined in grade 12 on the prop theorem. Remember, the next part is similarity and stuff, but today's lesson, we're focusing on proportionality theorem. What we want to do, solve for x. Now, you don't just solve for x, you need to give reasons. So the first thing what we're going to say is, because we have a parallel line here, perfect. That's what we are looking for. We're looking for one triangle that has a parallel line. That's it. That's what we are looking for. Right, guys? Looking for triangle that has a parallel line. Now, we can say NK over Ln is equal to, because we're solving for x, NK over Ln is equal to Kp over MP. Only for this I'm writing it because in later on we don't need to write out this whole thing here like this, okay? Later on we just need to write x plus 1 over 3 equals 4 over x. Now the reason what we write here is prop theorem, because NP is parallel to Lm. Now we substitute all the variables and we solve, okay? Let's substitute the variables. X plus 1 over 3 is equal to 4 over x. So we have provided the reason, and now we are solving this. So we're going to cross multiply. We're going to get x squared plus x is equal to 12. We got x squared plus x minus 12 is equal to 0. So you got x minus, we have x minus, x plus 4, x minus 3 is equal to 0. So x is equal to -4, or x is equal to 3. So we need to reject this because we are solving for x. Distance can't be negative, and we're going to accept this. If you're looking at this example and reading it, in triangle ABC, DE is parallel to BC. Should put the parallel line here, right? AB is 28. AB, the entire distance AB is 28, right? So I'm going to write 28 on this side because the entire distance is 28. AE to AC, AE to AC, AE to EC, not EC, AC. So what is AE? 4x. You have to write x, right? And AC needs to be 7x. In other words, EC will be 3x. Remember, they said AE is 4x, and AC is 7x. The entire thing is 7x. So obviously 4x plus 3x will give you 7x, right? So 4 is to 7 means 4x is to 3x. Determine the length of BD. Now remember, the same ratio can also be given like this. You can also be given a ratio like this. AE over AC is 4 over 7. So AE is 4x is to 7x. You can also be, this ratio can also be given like this. But we want the length of BD. Now, what is the length of BD? So we're going to say BD over AB. Okay. Now, in prop theorem, it's not only this distance over that distance is equal to AE over EC. It's also AD over AB equals AE over AC, or CE over CA equals BD over B. All the possible combinations around the parallel lines, okay? So let's do AD over BD. No, we're not doing AD over BD because we want to find BD. So let's say BD, we're saying BD over AB because the entire distance AB was given, which is 28. So we're saying BD over AB equals EC over CA. You can say CA or AC, it means the same thing. So what we're going to write, prop theorem. Why it is proportionality theorem? Because DE is parallel to BC. And remember, that's what we proved above. Okay. And now we fill in all the information and solve. Take AB across and cross multiply. So BD is equal to, what is AB? AB is 28. And what is EC? EC is 3x over 7x. So 3 over 7. 28 divided by 7 is, if you're writing 3x over 7x, no issues. You can write that down, but the x's cancel out. So 28 divided by 7 is 4. 4 times 3 is 12 centimeters. Okay, so what's the length of BD? 12. Right, so I hope you guys understood that. 12 centimeters. Next problem. So these are just basic diagrams. As long as you have a parallel line within a triangle, it's always prop theorem. So in triangle ABC, A should be here. In triangle AC is parallel to DE. BC is 16. The entire distance, again, the entire distance is 16. So I'm just going to write it a little bit further away. At BC is 16. BD to BC. BD to BC. Again, BD is 3x. And BC, the entire thing is 4x. So in other words, that must be x. Okay. Now you can say BD to BC is 3 is to 4. That makes sense. Right. And now AE is equal to 6. AE, the distance AE is 6 centimeters. Determine the length of BE. Determine the length of BE. Now we want the top distance. So we're going to say BE over 6. See what I'm doing now? I'm writing BE over, okay, let's just write the letters. BE over AE. BE over AE is always around the parallel line point. It's always about the line. So BE over AE is equal to BD over CD. And what are we solving for? We are solving for BE. So we're going to cross multiply that across, right? And we're going to say this is the prop theorem, right? Why it is the prop theorem? Because ED is parallel to AC. Right? That's all you need to say. Take the AE across and find BE. What is AE? AE is 6. What is BD? 3x. And what is CD? X. So there was no need for 16 here. Oh, the reason why they give you 16 because you can take 16 divided by 4 and then you can get 12 and 12 and 4. You can work with that as well. All right, so there was no need to give 16 here. Anyways, x and x cancel out. 6 times 3 is 18. So we're getting 18 centimeters. Was it centimeters? Yes. So what is BE? The length of BE is 18 centimeters. So first we wrote down, yeah, so you're basically going to get 3 marks for a question like this, right? Now you get more confusing problems like these ones, right? Where you have multiple parallel lines within a triangle. I'll teach you a trick. Now, what's the trick here is to identify all the possible proportionality theorem triangles, okay? So let's look for a triangle that has a parallel line. And now the trick to solving this problem is, okay, you will say, okay, no, there's only one parallel line with a triangle, but not really. Look at it. So you got triangle. What triangles you have? You got triangle BCK, right? You have triangle BCK, where DE is parallel to CK. What else? What other triangles you have to work with that you can apply prop theorem in? Anyone? Mishka, what other triangles you have that has a parallel line? Look, the trick is to extend this parallel line here, then you can see all of them. You see? Now you can see ADE. You have another triangle which is ADE. Is there another one? Found one there, one here. Is there one more that I can't see? ADE and BCK. Is there one more? No. DE is parallel to CK and then PK is parallel to DE for the second one. Yeah, just those two. All right, so we can work with these two, all right? It's just these two triangles that we need to focus on when doing prop theorem. Now, let's read the story. In triangle ABC, CD, and CD to BD is 2:3. CD to BD is 2:3. So you're going to say 2x is to 3x. AK is 3/4. AK is 3/4 BK. Now, very nice. See how this is written. AK is 3/4 BK. So what you're going to do is simplify this ratio. You're going to say AK, divide both sides by BK, all right? AK over BK is 3/4, okay? So what is AK? AK is 3. You can't use X now. You finish use a variable for one side. If you're dealing with the other side, you need to use another variable like 3y. And what is BK? BK is 4y, okay? Now remember, this is an unknown quantity. Anyways, let's see. This is an unknown length. KC is parallel to DE. That information is given. That's why we looked at all these prop theorem triangles. CK and AD intersect at P. AP to PD. We want to find what is AP to PD. Now, I'm not going to find AP to PD. I'll write it out like this. AP over PD. Instead of writing that ratio, I'd rather write the ratio as a fraction. Right? You can write ratio in ratio form like this with the two dots, or you can write it as a fraction. So I'm going to start here. I'm going to start with AP to PD. Now, AP to PD. Here we are here. AP to PD is equal to AK to KE. Isn't? But now we have a problem with this triangle because what is the distance KE? We don't even have KE, but now you want to work with KE. So for now, I'm just going to write prop theorem. I'm going to move that to the bottom because that idea is going to be there. Prop theorem. So I know I have AP to PD. That's what I need to find. I have AK, but I don't have KE. So now I have a new problem. I need to find KE. Prop theorem because PK is parallel to DE. Okay. Now, remember, the idea is to find KE, and we can go and find KE. How are we going to find KE? We need to look at the first triangle. So this was using triangle ADE. Can you see? I'm only using triangle ADE to find AP to PD is AK to KE, but we don't have KE. That's an unknown. So now use the first triangle BCK. So you're going to say in triangle BCK, I have CD over DB CD over DB equals KE over EB. There, we got KE over EB. But now we got a problem because we don't have EB. So I need to change the ratios at the bottom. So don't put, so say CD, we got the entire ratio KB here, right? So you need to say CD over CB. CD over CB is equal to KE over KB because I have KB, which is 4Y, right? And that's also a prop theorem, but different pair of parallel lines. Prop theorem because CK is also parallel to DE, okay? Now, we can solve this problem because we are finding KE. If I can find EK, we are sorted. So this was equation 1, by the way, right? And this is equation 2. Okay, you don't need equation 2. You're just going to say substitute this into equation 1. CD, what is CD? CD is 2. CD is 2x and CB is 5x. KE is unknown. That's what we're looking for. And KB is what? For Y. Now you cross multiply. Remember the x's cancel out. And 4 times 2 is 8. So KE is 4 times 2 is 8. 8 over 5. 8 over 5 what? 8 over 5y. So what is KE? 8 over 5y. And now you can find that by 4y minus 8 over 5y. You can write 8 over 5 or you can write 1.6y. Doesn't matter. All right, because this here can be simplified into a nice decimal fraction. Okay, so we got KE. Now we're going to take KE and substitute into that top one. So AP over PD is equal to what's AK? AK is 3y. And what is KE? KE was 8 over 5y. Right, so now the y's cancel out. And now we have 3 times, it's 3 divided by 8 over 5, so 3 times 5 over 8. So what we have? 15 over 8. This implies, write it in the original form, AP to PD is equal to 15 is to 8. Write it in final ratio form. I hope you guys understood that. All right. So there's no difficult geometry here. It's exactly what I have taught you today, right? We are not using circle geometry and stuff to solve anything. We are just taking ratios and solving ratios. That's it. Right. You're just trying to understand what these ratios are. It's not 3 and 4. It's a simplified ratio. So you got to put the x, you got to put the y. If you use x here, you need to use y's here. If you have a third ratio, then you need to use another variable like a, b, c. You have so many letters to use, right? Great, guys. Let's continue. Next question. Right, there are simple diagrams, there are difficult diagrams. All right, it's all about how you think. Now, watch here. In right triangle MNP, right? QR is drawn parallel to NM. So I don't think you can see the parallel lines. Let me draw it bigger. QR is parallel to NM with R the midpoint. Okay. See what they're telling us? They're testing us on the midpoint theorem. Great. What is R? R is the midpoint. What does midpoint mean? You can go and use the prop theorem as well. You can forget about the midpoint theorem, but if you use the midpoint theorem, no issues, right? So R is the midpoint of MP. It means that this is X and this is X, right? NP is what? NP is 16. Oh, you got to use the midpoint theorem. NP is equal to 16. The entire distance is 16. Let me write 16 on the outside here, right? QR is 6. and determine PQ and RP. What is PQ? This distance over here. We don't know what is PQ. We need to find this, and we need to find RP. We find the value of X as well. Ooh. Okay, first what we need to say is that we have a parallel line and we have a midpoint. So this is case 2 of midpoint. If you clearly remember the midpoint theorem, you get a midpoint theorem which is like this. Right, so you got A, B, C. This is done in grade 10 towards the end of the year. Right, so those two sides are the midpoint, right? So if the midpoints are given, if the midpoints are given, so that's exactly what's given. What's your conclusion here? Your conclusion here is that DE is parallel. DE is parallel to BC, and DE is equal to half BC. And what we say, midpoint theorem. The reason, very important, midpoint theorem. Right, and that's the given stuff here. Exactly what's given here, the midpoints are given. Midpoints given. So that's a conclusion. So basically your conclusion is, if then this will become X, and that will become 2X, and it will become parallel. So the red part is your conclusion. Now the next one, case 2 of the midpoint theorem. Case 2 of the midpoint theorem. Uh-huh. All right, so in this midpoint, in the second case, one side is given as a midpoint, right? So what we are given, we're only given that one side is a midpoint. Not midpoints are not given. All the midpoints are not given. All we are given is that AD is equal to BD. AD is equal to BD, and we are given parallel lines. DE is parallel to BC. Now, if you're making either or conclusion, you're always making two conclusions here. Right? So the conclusion here you're making, the first part is that AE equals EC, or the second part that you're making a conclusion is that DE is equal to half BC. And the reason you ran right is line through midpoint parallel to second side. Line through midpoint, line through midpoint parallel to second side. Line through midpoint parallel to second side. Okay. Now, that's a conclusion. So we have a similar situation here that we need to do. So I've already written everything here. Right, so let's see. The information is all given here. Let's move this diagram to the bottom and solve. Guys, if you have any question, please ask, all right? Now, remember, I put question marks what we need to solve. So first, what we see is that PR is equal to RM. That midpoint was given because I put X and X. Let's mark it again. And that parallel line was given. But now this was given as 16, all right? So clearly we can say that, all right, we can say PQ equals NQ. PQ equals NQ, which is equal to 8 centimeters. And the reason is line through midpoint. Parallel to second side. Line through midpoint parallel to second side, okay? Line through midpoint parallel to second side. So that's part is sorted out. That's done. So this is 8, all right? And this is also 8. Now, how can we solve for x? To solve for x, how can we solve for x? Well, they didn't ask for mn. Mn is basically 12, right? Oh yes, there we have a 90-degree here. That 90-degree, we can transfer this 90-degree here, right? So we can say angle Q1 is equal to angle N is equal to 90 degrees, right? And the reason is corresponding angles. Why is it corresponding? Because NM is parallel to QR, okay? Okay, so now I think we can just use Pythagoras here. Either way, you had to use Pythagoras. If you are going to say this is 6 and that's 12, you can move the 12 at the bottom. You still have to use Pythagoras for the 2x. So yes, you got to use Pythagoras as well here. So it's easy, all right? So to solve for x, you're going to say x is equal to the square root of 8 squared plus 6 squared, which is 64 plus 36, which is 100. Square root of 100 is 10, and that is Pythagoras theorem. So I think they asked us for PR. This implies PR is equal to 10 centimeters. Was it centimeters or units? Not sure. What was it? Centimeters, right? So that's how you solve it. Are we good, guys? All right, excellent. Let's continue. Right, so now this is a problem with taking ratio of areas, and I like this problem because remember that's what we kind of like started off with, and now they're going to ask a lot of questions about ratio of areas. Now let's see. In triangle ABC, angle A is 90. Angle A is 90 degrees. All right, so we have 90 degrees here. Now when you get 90 degrees, you can also use Pythagoras. PQ is parallel to AC. Those are parallel lines here. PB to PA is 3:1. PB to PA is 3:1. So 3x is to 1x. AP is equal to x. Okay, they're telling us AP is x, so I already made it 1x to 3x. QC is y. Right? Find x and y. Find x and y. I think there's something missing here. PQ PB is equal to PA. PB to PA. Find x and y. Sorry, not find x and y. The questions are here. Let's take this out. The questions are at the bottom. Calculate QC to BC. QC to BC. So we're going to say QC to BC. QC to BC is equal to AP to AB. QC to BC is equal to, let's see if the order is right. QC to BC is AP to PA. AP to AB. Yeah. This is prop theorem because PQ is parallel to AC. Now, yeah. What is AP, guys? AP is X. And what's AB? AB is 4x. Yeah, because you need to add the small x. The entire distance AB is 4x. Right? There's a line PQ which divides the two sides in the same proportion. Right, so now we got quarter. So this is quarter. This implies QC to BC is equal to 1:4. QC to BC is 1:4. Now, area of triangle ABC, the entire big triangle to the area of triangle PBQ. Now, obviously, you can't draw same altitude because this small triangle is sitting inside the big triangle. So you got a common angle here, right? Now, because this is y, you need to make this 3y, right? So now it's easy to solve. What's the area of triangle ABC? Half. We are using the sine rule, guys, right? ABC, half 4x, 4y, sine B. Half, what about PBQ? PBQ, 3x, 3y, sine B. Now you can clearly see that sine B cancels out, half and half cancels out, the x's cancel out, the y's cancel out. 4 times 4 is 16. And you got 16 over 9. That's your answer. Right. So quite simple, guys. Next question. As you can see, the problems are getting a little bit more challenging, right? Like especially this one. Let's see if it's a challenging problem. We don't know. So let's see. FE is parallel to AD. FE is parallel to AD. And we got ED parallel to AC. We got ED parallel to AC. That's why I've already color coded it for you. So you know exactly which lines are, which triangles are. Prop theorem. Is there a third one? The two green ones, the two red ones. Is there a third? I can't find. All right, so let's see if the problem is prove that BD over DC over DC is equal to BF over FD. That's what we want to prove. So first, part A. Working with this triangle here in part A. Yeah. Okay, sorry. Let's move part A on this side. Doesn't look difficult. If we want to find BD to DC, which triangle should we choose? Yeah, we're choosing the triangle that has the green arrows. BD to DC will be BE to EA. Be BE to EA. Right? And that's prop theorem. Why is it prop theorem? Because ED is parallel to AC. Right? Now, what about the next one? They wanted BF to FD. What about BF to FD? If you try BF to FD, you will find now you are working with the triangle that has the red arrows, right? So BF to FD equals BE to AE. And guess what? Part 1 and part 2 are exactly the same because you got BA to EA, BE to EA, BE to AE, same thing. And this is prop theorem, proportionality theorem, because we have EF is parallel to AD. Okay, so this implies, what does this imply? This one cancels out. BD to DC is equal to BF to FD. D. That's it. Right, you can clearly see that this is equivalent to this. All the ratios are equivalent, so obviously first and second one will be equivalent. Now let's try to get the next one now. What is BD? BD is equal to the square root of BC times BF. BD BD is equal to square root of BC times BF. Where's BC and BF? BF is here, and BC is the entire big one. All right, let's try squaring both sides. This implies BD squared is equal to BC times BF. Let's try squaring both sides and then split up the BD into two parts. BD times BD is equal to BC times BF, okay? Now, let's take out this BD at the bottom. Now, I can take one of the BD and divide it by BC. Right? And I can take one BC. I took BD and divided by BC. And I'm going to take BF and divide it by BD. Wait a minute, but now we got BF over, whoa, we don't have BF. We got BF over BD. We got BD over, is BC equal to BD? That's what you check. BC, 1 second. BD over BC. BD over BC equals BF over BD. Ah, come on, guys. Look, we're going to start with BD over BC, right? We're going to start off with BD over BC and come to that conclusion. So I was just checking if I expand this whole thing, what am I getting? Right, so you're going to start off with BD over BC. So you're like restarting the whole process from the beginning to come to that conclusion. So I'm going to take all this out because this is your thinking, this is your idea that you are working with. So let's take this idea and put it one side. Because remember, you need to come to the square root thingy there, right? The conclusion needs to be the square root. So I'm going to take this idea and push it one side, and then we need to do the proper proof. So it's important how you think. So I kind of like made sense with it just by opening this equation up. So I am going to start with BD. Right, so I'm going to start with BD over CD. No, what was it? BD over BC. BD over BC. BD over BC. So I'm using these green parallel lines is equal to BE over BA. What's the reason? Prop theorem. I'm just going to copy and paste there from the bottom because the green parallel is ED is parallel to that. I think it's the same thing, but written in a different way. Yes, that's prop theorem. And for the next one, I need BF to BD. BF to B. It's the same thing, man. It's just like repeating process A. BF to BD. BF to BD is the same thing as saying BE is the same thing as saying BE is to BA. And that's prop theorem from the second part. Right. And now, because those two are equivalent, we can just say this implies BD over BC is now equal to BF over BD. Now, if you cross multiply, you get BD squared is equal to BC times BF, right? And now if you square root both sides, you're going to get BC. Therefore, BC is equal to square root BC over BF. Now, why we don't say plus minus? We don't say plus minus square root because we are working with distances. Distances are all positive, right? BC has to be greater than 0. Anyways, we have proved it, okay? So it was like doing the same thing in part A, but with different ratios. We're taking the ratios which are the entire side of the triangle instead of parts. So it's like a similar question as A. You're basically doing the same thing in A, the same thing in B. It's just the ratio is just written in a different form, right? Thanks, guys. Okay, I'm gonna try to solve one question at a time. Okay, let's just take the whole thing. It's fine. Watch here. In triangle ABC, right? In triangle ABC, P is the midpoint of AC. P is the midpoint of AC. So if this is the midpoint of AC, so that will become X. See where I'm putting the X? And this will become the X, right? So that part is X, and that part is X, okay? PB is parallel to BP. Now, again, you got parallel lines. Make sure to extend this parallel line to this side as well, right? Okay, no need because you can see the two triangles already. AR to AB. AR to AB is 3:5. So AR can't be X now. You must put 2Y. RB, you must put 3Y because AR is 3 and AB is 5. So 2 plus 3 will give you 5. That's correct. CR and BP intersect at T. Determine with reason the following ratios. What is AS to SC? AS to SC. We're going to use this triangle here. I'd rather write out the triangle that you can work with, all right? Let me write out the triangle that we are actually working with, all right? So in triangle ABP, that's a triangle I'm working with. In triangle ABP, what do I need to find? I need to find AS. I need to find AS to SC. Did they say AS to SC? AS to SC. No. Let's work with this triangle first because I want AS to SC. I can't work with that. I need to work with this first, right? So let's see. AR to RB. AR to RB is equal to AS to SP. Right, that's because of prop theorem. Please give the name of the parallel line. RS is parallel to BP. Right. Next, fill in all the information. What is AR/RB? AR is 2. What's RB? 3. You're going to write 2y over 3y. So the y's will cancel out. AS, AR to RB is 2 over 3. So that's basically AS to SP. Right, so we got AS to SP, 2 over 3. But now AS to SP is 2 over 3. It's a simplified ratio. So what you need to write down over here, AS to SP You need to write down over here, AS is 2A is to 3A. Okay, AS to SP. So I'm using A's over here, right? So this implies X is equal to 5A. Now problem solved because you got 5A as X. So therefore what? So therefore AS to SC is easy now because you got 5A and 5A. Those are midpoints. So what is AS to SC? AS is 2A. And what is SC? SC is 3A plus 5A, which is 8A. And 2 over 8 is quarter. Right? So I hope you guys understood that. What is RT to TC? Now there's enough information on this diagram. So let me just take this diagram. Right, so I will define RT to TC. RT to TC. So RT to TC, that's what I want to find. So I'm just making the dots here that we're looking at this triangle. So in triangle, RCS. In triangle RCS, RT to TC is equal to SP to PC. Is prop theorem. Prop theorem because PT is parallel to SR. What is SP? SP is 3A. Come on, guys. SP is 3A and PC is 5A. So what's RT to TC? 3 out of 5. Great. Now let's move on to the next part. Part C, we want to find area of triangle TPC, area of triangle TPC. Oh yes, by the way, what was RT to TC? It was 3:5, right? So now we need to put different variables here. We put 3K is to 5K. Right. Now, area of triangle TPC, and RSC. So we have a common vertex, common angle. So we have to use the sine rule. So half 5A times 5K sine of angle C divided by call it angle C1, all right? Make it angle C1 because there's two angles by C. You can't call it angle C now. The angle C is the entire thing. You call it angle C1. Next one, half RSC, all right? RSC. So what is this? 8K. What's on this side? 8A. And sine of angle C. So you can see sine C is cancelled out. All the variables cancel out. the only thing that you are left with is 25. 5 times 5 is 25. And 8 times 8 is 64. 25 over 64, right? So nice problem, guys. Now, what is the converse of proportionality theorem? The converse is simple, right? All you need to use is this line divides sides of triangles in proportion. So I'm just going to explain this to you, and we don't need a proof for this. That's why I'm just going to explain it and the reason that you need to apply for a converse of the proportionality theorem. Now, converse proportionality theorem says this. If a line divides two sides of triangle in proportion, in other words, you already have that the sides are in proportion. That's a given condition, so right? Sides are in proportion. Your conclusion is, what is your conclusion? Your conclusion will be definitely parallel lines, right? Lines are parallel, and you will write this reason down. Line divides sides of triangle in proportion. Okay, not the other one. The other one was for midpoint theorem. Line through midpoint parallel to second side. This is not a midpoint. It's a line that divides sides of triangles in proportion. Okay, it's a line. Which line? DE. Line DE divides the sides of triangles in proportion. You have to mention that. Please don't mention prop theorem and stuff. You can't mention prop theorem because you don't have parallel lines. You're proving parallel lines. Right, so now let's take an example of this and prove. You have to use a numerical example to verify the truth, right? To test the theory. Now let's look at this. In triangle ABC, point D is on AB, and E is on AC, obviously. All right, so DE is just basically a line which is on different. Right, so now if AD is 4, BD is 12, AE is 3, EC is 9. Prove that DE is parallel to BC. Easy. So first you're going to say AD over BD is equal to 4 over 12, which is 1/3, and AE over EC is equal to 3 over 9, which is 1/3. This implies AD over BD is equal to AE over EC. But this was given already. Prove that DE is parallel to BC. Therefore, that's what we notice, right? So this here kind of like becomes a given condition. Now you can say, therefore, because the size of triangles in proportion, you say, therefore, DE is parallel to BC. Sides, line divides sides of triangle in proportion, right? You have to say line divides. Don't just write sides of triangle in proportion. Write line divides. Write it properly, okay? Line divides sides of triangle in proportion. Right, guys? Now, next.
So,
Yes.
could you also say converse the midpoint theorem? Is that like a rule that's
No.
accepted?
No, don't say converse midpoint theorem.
Okay.
Use line divides sides of triangle in proportion.
Okay.
Right. Great. And let's look at this example. Similar. Right, so now we're moving on to converse. Now, remember, now when we're doing problem solving, we have both the theorems to work with. Right, so guys, I just want to finish this up. I don't have much questions left. I only have like a few left. Quick. In the sketch alongside, AB is equal to 15. Right, so we have AB, which is 15. BC is 10. These are actual length. 15 and 10 are centimeters, right? AE is 5 over 3 AD. So AE over AD divided is equal to 5 over 3. So 5x is to 3x. What is AE? AE is 5x and AD is 3x. So then obviously this will be 2x, right? Now, because this side is already parallel, we want to prove that GD is parallel to FE. So what we can say is that AG over GF. What is AG over GF? We are choosing this triangle here in the side, in triangle ACF. So in triangle ACF, I'm not even looking at the other side of the triangle, looking on the left side. In triangle ACF, we have AG over GF equals AB over BC. Right? And we're going to say prop theorem. Now, why are we saying prop theorem? Because we got BG parallel to CF. Now, what is AB over BC? AB over BC is 3 over 2. Right? AB, sorry, it was 15 over 10. That's how we got 3 over 2. It was 15, 3 over 2. And this implies that AG, this implies in triangle. We also know that in triangle AFE, in triangle AFE, we know that we have AG over GF is equal to AD over DE. And both of them are 3 over 2. Therefore, GD is parallel to FE. And please write line divides sides of triangle in proportion. Triangle in proportion. Right, guys? Nice. That's all they needed, right? Prove that it's parallel. Now, we're moving back on to problem solving now. Let's see quickly. Try to solve these quick now. That's the only problem here. AB is 9. Right, so I'm going to write it in the side because the entire distance is 9. PB is 3. PB is 3 centimeters. And AB is 9. So obviously that is 6. We can take the 9 out. All right. PQ is 8. Looks like we've solved a problem like this before. QC is 5. QC is 5. APQ is 90. APQ. APQ, that angle is 90. All right. APQ is 90. Determine the length of BC. How are you going to find the length of BC? There's nothing given here. To find the length of BC, okay, first find what is AQ, right? Let's find AQ. We can use Pythagoras. So AQ is equal to square root of 8 squared plus 6 squared, which is 10. That's from Pythagoras. So we can write down 10 here. We have a 90 there, a 10 there. Are these lines parallel? No. Any other information was given here. AB is 9. BP is 3. PB is 3. QC is 5. So that's 15. That's 9. QC is 5. Determine the length of BC. If I can get this here to be 90, then I can say it is then it is possible. But how is that 90? How can I get that to be 90? Okay. Watch. This is where we're making a mistake. In order to get angle B to be 90, remember this side is already 15 and this side is already 9. But I need a 90 degrees to use Pythagoras. That's why I'm stuck. But now in order to get angle B to be 90 degrees, I need to prove that these two are parallel. Now, how do I prove this is parallel? We just learned what? We just learned the converse of the proportionality theorem. Line divides sides of triangle in proportion. So you need to say AP over PB. What is AP over PB? 6 over 3, which is 2. And AQ over QC is 10 over 5, which is also 2 over 1, right? Therefore, AP over PB is now equal to AQ over QC. This implies PQ is parallel to BC. Why is it parallel? Because line divides sides of triangle in proportion. This implies, okay, after you get that's parallel, therefore angle B is equal to angle P1 is equal to 90 degrees because of corresponding angles. Why is it corresponding? Because now we can say PQ is parallel to BC. See how powerful this proof is. Right, PQ is parallel to BC. Now we can say BC, we can apply Pythagoras now. BC is equal to square root of 15 squared, the entire big triangle. 15 squared minus 9 squared, the other side, which is Pythagoras. Right, that's 90 now. Pythagoras theorem, I think you should get, if you remember Pythagorean triples, 3, 4, 5, 6, 8, 10, 3, 4, 5, 6, 8, 10, 9, 15, multiplied by 3, 12. 15 squared either way. 15 squared is 225 minus 81 is 144. Should get 12 centimeters. Right. So the length of BC is 12. So be careful. You can't just assume stuff here. You got to prove it first and then use it. All right. Right, guys. Let's see. Next problem. In the sketch, DG is parallel to EC. The parallel lines are given, right? DG is parallel to EC. EF is parallel to AC. EF is parallel to AC, the entire big one. So I'm going to draw it bigger here, right? Right. That's parallel there. Is there any other parallels? I can't see it. All right. Now let's see. AG to GC. AG to GC is 4:5. So 4x is to 5x. BF to FC. BF to FC. BF to FC. Why are we doing this one? It's an entire big one here. BF to FC is 2:3. So 2y is to 3y. BF to FC. Determine BD to DA. BD to DA. BD to DA. How are we going to determine BD to DA? DA. Okay. BD to DA. There's EB over here, which is kind of like, okay. So we're going to start with EB over EA. looking at this side triangle here. In triangle BCA, we want BD to DA, right? Okay, let's look at the front one, the top one first, right? So let's say AD over DE. AD over DE equals AG over GC. And obviously you need to write prop theorem because why is it prop theorem? Because DG is parallel to EC, right? Now, what is AD to DE? What's AG to GC? 4:5, so 4/5, right? So now we're gonna write 4A is to 5A over here. Now work with the other triangle. Work with BE. What do we want? We want BD. I can't work with BD at the moment. I can work with BE to EA. You always need to work with a triangle that has a parallel line. How can you work with broken parts here? So we're working with BE to EA is equal to BF to FC. Right, again, prop theorem, normal story. Prop theorem because EF is parallel to AC. Right, now, what is BF to FC? Actually, we found BE here now. BF to FC. BF to FC. We have to find, we're solving for BE over here. BF to FC. So we're going to write BE over, what is EA? E to A is 9A. BF to FC is 2/3. Now you need to take the 9A across and cross multiply. So BE is now equal to 2 times 9 is 18 divided by 3, 6A. So what is this? What is BE? 6A. Now you can find the ratio that they are looking for. The ratio that they're looking for is BD to DA. So what is BD to DA? BD is 6 plus 5, which is 11A. It is 11 to 4. DA is 4. 11 is to 4, right? You should write that at the end, okay? So BD to DA. Eleven is to 4. 11 is to 4. What is AB to DE? AB is the entire distance, right? So say that's 15A. And what's DE? 5A. That's easy one, all right? That's just 3:1. Yeah, 3:1. So easy this problem was, like 1 mark question. Yes, I just want to do this and then I will end off, right? Right, so one question at a time. All right, so we want to determine the value of, just copy this to a new page. Determine the value of, I think we want to find a ratio of areas. Right, so we can find the ratio of this area here. Area of triangle STX, but read the story. In the sketch, VW is parallel to TU. VW is parallel to TU. Make sure you put the parallel lines because there are many triangles here. You can see, I can see SXT, TSX. Then I can see USX. And then I can see another parallel here, the entire big one. So I can see three different proportionality triangles. Okay. And even this one is parallel. This one is parallel to this one. So, well, in this case, just one of them now, right? Yeah. Now there's four different proportionality triangles. Anyways, I'm going to explain this. Uh, TX to TU. What is TX to TU? TX to TU. TX is 4 and TU is 7. So 4x is to 3x, all right? 4x is to 3x. Let me not use x now because I got like a capital X there. Let's use ABC. 4a is to 3a. STX. Where's STX? STX. So I want to find the area of this triangle, STX, over the area of triangle SUX. SUX over the second. All right, so if you want to find the area of the triangle, think of this as the base, all right? You have a common altitude here, right? So you have a common altitude, you drop down a perpendicular height here. There's triangle 1, and this triangle is obtuse, the height is outside, right? So it's just half base times height, half base times height. So what's the answer here? Half. What's the base? STX, right? 4a and height, h. Half. What's the base here? 3a times height. All that cancels out, you're getting 4 over 3, right? Just 4 over 3. Now, what's part B? Guys, we have done this before, right? Just revising now. You just have to keep on solving problems to master the concepts. And you can see you either get a common height or a common angle. That's it. Let's look at the next one. TVX. Let's do this on another. Copy this again and do it separately, a separate diagram. Right, so we want to find the value of this now, right? What we had for 4a, we had a 4a and we had a 3a here, right? Great. TVX, where's TVX? TVX, okay, this one. And we got TVX, okay, and what's the second one now? STX, STX, TVX and STX. STX is no issues. What is this? Is this common height? STX and TVX. Yeah, it can be a common height because look at the base on this side now. Yeah, look at the base on this side. Uh, the bases will be on this side. There's a common height problem. Yeah, the draw common height. Right. So looking at the small triangle over this entire big triangle here. Right. So there, I drew an altitude. This is an obtuse angle, so the altitude is outside. This is an acute angle triangle. So the altitude is on the inside, the height. So half base times height, the base will be TV over VS, right? So let's see, half, what's the base of TVX? TV times height, half, VS times height. So what we're getting, TV over VS, but we need to find what is TV over VS. We can use prop theorem, yeah? We're going to use this triangle. In triangle S, which triangle should I use here now? Because you have transferred this on this side. If I'm going to use this triangle, okay. I need to use this entire big triangle. Yeah. So this green parallel lines. So this will be 4B to 3B. 4B to 3B. So you need to say this, I think. You have to say that TV over VS is equal to TX over XU. Right. That's because of prop theorem. Because Vx is parallel to SU. And now you need to say Tx over XU. What is Tx over XU? That was given. T is 4 over 3. There, 4 and 3. So TV over Vs. This implies TV over Vs is equal to, what is TV over Vs? Equals to 4 TV over Vs. TV over Vs is equal to 4 over 3, yes. It's the same thing as saying Tx over Xu. Right, so guys, we got 4 over 3 here as well. Now, yeah, next part. And calculate the value of the next triangle now. And there's one more after this. Paste it here. Right, so area of triangle SVW. I'm just putting all the stuff that we had. Parallel, parallel, right? And we had this at parallel as well. Right, let's see. Area of triangle SVW. SVW. This entire one on top. Now let's check what this here has now. SVW. And area of STU. STU. Now SVW is this part over here. And STU is this entire big one. So they have nothing in common, right? So it has a common angle, not a common altitude. What I mean, nothing in common as in like doesn't have common height. It has a common altitude. Sorry, it doesn't have a common altitude. It has a common vertex. In other words, a common angle. But we got a problem because we don't have SW and VU. So we're going to use 3K is to 4K. You need to write that out first. You need to say, let's write this out, half SW, SV. Yeah, I suggest find SW over WU. You're going to be lost. Let's find SW over WU is equal to SV over VT. SV over VT. Now, SV over VT is now equal to, what is SV over VT? SV over VT is 3 over 4, right? Because 3B over 4B. Now, this was because of prop theorem, because VW is parallel to TU. Now, we're almost there. This is half. We said we are using the sine rule because it has a common angle. Half 3K, 3B sine of angle S, half, what is ST? 7B, 7K, 7B, sine S. Now you can clearly see sine S cancel out, half cancel out, all the k's cancel out. You got 9 over 49. Right, so last one, guys. Right, and then we can end off. 9 out of 49. Yeah, that's great. Area of TVX, right? Area of TVX, which is this one, over area of SUX. SUX. How are you going to find this? This doesn't even have a common vertex, neither does it have a common height. Because it's like there's another triangle in between separating these two. Where am I supposed to draw the altitude? Right, so we got a big problem here. But, I want you to focus on what you just solved prior to this, because it's a followed on question. We solved just now, we solved these three problems. Maybe we can use those three problems to simplify this. Right, so we got area of TVX. Did we solve for that before? Yes. Area of TVX, okay, we got that. And area of SUX, where's SUX? There. So what you can do is you can take the first two areas and multiply it out together, because this one, it wasn't so bad. Right, so what we're doing is we're taking the areas of the first two parts and multiplying it out together. So this is, see, area of triangle STX over area of triangle SUX times multiplied by area of triangle PVX over area of triangle STX. See what happens, guys. Check what happens. Isn't those two areas kind of like cancel out? So you're finding TVX over SUX. Nice. But we can't cancel them out. We just take the two answers and multiply it out. Right? When you have unrelated triangles, that's what you gotta always do. And this question like this came out in the past paper. So what was the first answer? The first answer was 4/3. 4/3 times 4/3. That's it. So this here was 4/3. No, wait. What was the area of the first part? It was 4/3. Area of the second part was also 4/3. Yeah. 4/3 times. So we're getting 16 over 9. And I don't think there's any other way. Because two unrelated areas. STX. Yeah, quite challenging. Right. So you will never get a question independent like this. You won't get an independent question like this. But if you do get it, you have to look at which triangle lies next to this triangle over here, with the altitude or with the vertex. Right. So I'm looking at this triangle over here, STX. And that's the one that we kind of like canceling out, STX. And is STX also part of TXV? Yes, with common angle. So you got to be smart about that, right? I had